So in this lesson we're going to add the shark to the world, and the shark is going to be keyboard controlled. So I just want to give you a tutorial here on how you can do some of the interactions with Greenfoot. So here's my shark that I've already created, and it's facing 0 degrees, so it's lined up to Greenfoot. And in here, what we want to do is we want to start using the Greenfoot class. So you can open up the Java documentation, and Greenfoot has ways of dealing with the keys, which is what we want here. There are other things, but we're going to really just talk about the keys. So here's how you access them. That's how they're defined. And we're going to use the isKeyDown method, which will return true or false to tell us whether or not the key is being pushed. So in my code, I could do something like if greenfoot.isKeyDown, and I could try left. Then to move it left, it's moving back, kind of. I mean, move might not even be the best method to use here because move only goes the direction it's facing. So it's going to go backwards. Basically, I just want to show you that this isn't really the behavior that we want. So if I'm tapping my key now, the shark moves, but it only moves left and it's going backwards. So I don't know about you, but I haven't seen too many sharks that swim that way, so we can certainly do better. Now, what I want to do is I'm going to use a method that's already in here for me. It's a method in the actor class, so let's go and bring that up. So in the actor class, there's a method here called turn towards, and that'll handle the way the shark swims for me so that it's swimming the way I'm moving it. But in order to do that, I need to know where the shark is going before I move it. So let's bring up our code again, and that tells me I need a couple new methods. So public int next x, and what I'll do is I'll decide how far the shark has to go for the next x. So we'll start by getting the current one, and then I'll figure out how much it's going to change. So for now I'll assume that there's nothing, and I'll say if greenfoot.isKeyDown is left, then that means I need to move back. So I'm going to say dx is, and let's make the distance -5. Otherwise, well, we have to actually do another condition here because we have to test and see if the key is moving to the right. So then I'll make it +5. What I'm going to return then is the current x plus however much it needs to change. And it'll do it for left and right. Because I'm only looking at the x coordinate, I don't need to worry about y and handing out the up and down arrow keys. A method can only ever return one thing, and that's what I'm doing here, is returning that one value. So I need to repeat this again for the y coordinate. So I'll just quickly do a copy and paste here, move us along a little quicker, and I'll have to update everything here to be in terms of y. And it's one of those things about copy and paste, you got to make sure you get them all so that you don't have errors following you around in your code. And I'm talking about the up and the down keys this time. So one thing that you want to realize about it, and I talked about this previously, was that when it's moving down, the y value is actually increasing. So this code won't work right now because although to us normally if we were doing something up, we would think we'd be increasing the y value, but you actually need to decrease it here in order for it to work, because now by decreasing the value of y, it'll be rising. Remember, this is the way the locations are based, where 0 starts in the top left corner, and then as I move further down, the y increases. So moving down, the y will increase. It's a positive value. Okay. Now, first of all, this is an error. Well, it's not really an error, but it's something that we should avoid. And these are what I usually call magic numbers. This 5, -5, all this stuff in here. If you ever wanted to change the code, you have to go looking through all those numbers and figure out what they mean, which ones need to be changed, which ones don't. So ideally what we'd like to have here is a constant. Now, it's a constant that all sharks can use, and it's going to be how much they move by. So I'll let, I mean, I guess we can make it private, we can hide it. But because all sharks are going to move by the same amount, there's only one in our game anyways, but we'll make it static so that all sharks share it. and it's a constant, so I'll make it final as well. So this says only shark class can see it. It is static, so all sharks share it. It is final, so no one can change it. And let's call it the key move, how much the key is going to move us. So that means down here I should put this as key move. And that way, if I ever need to make any changes, I only need to do it in the one place. And that's where I've defined that key move variable. Okay, so now I know the next location. So I'm able to do something like this and say int next x is next x. Int next y is next y. Now what I'll do is I'll say turn towards the next x and the next y, and then set your location to be the next x and the next y. So there is a bug in here, but we can play at least right now, and you can see the way the key, now I know where I'm moving to, so I can tell it when I'm acting how to move. So I'll compile this, and we'll bring up Greenfoot. Now when I put a shark in, when I run this, as I said, there's a bit of a bug. Maybe you'll notice it here. No problems moving to the right, but moving to the left, every time I let go, it faces back that way. And if I move up, as soon as I let go, it's moving, pointing to 0. So what's happened is in our code, if we're turning towards the same location we were already at, then that's what it's going to do, is reset it to 0 degrees. And we want to avoid that. So really all we need to do is make sure that we actually have to move. And to do that, I'll put in a decision. So if the next x is not equal to the current x, or the next y is not equal to the current y, then that means I've actually moved somewhere new. And I have to make sure that I'm facing the right way. So the only reason I need to do this is because I've actually moved somewhere new. Now when I run it, that behavior's gone. And you can see that as I move the shark around, it stays the way I've touched the key. So sharks also have some other things that they need to do for us. Now we've programmed the keyboard onto the shark, and as you can see, that's pretty nice. It's not very much code. Each one is in a nice short method. But we need to make it eat fish. Now, to do that, we're also going to want to keep track of how many fish it's eaten, so we've got points. So let's add that here now to start. So private int fish count. And because it's not static, it's going to belong to each individual shark. They get their own. And that makes sense because if you had more than one shark in the game, you'd want to make sure each shark could have its own count. So all the initialization and creation, remember, happens in the constructor. So I'm going to go and use the shark. I need to call on the superclass to build an actor for me, and then I'm going to start playing with it. So here I'm going to say fish count equals 0. I haven't eaten any fish yet. So this will initialize the shark the way I intend for it to do, and now we're going to program the code for it to eat a fish. The other thing you might notice here is I put this underscore here on purpose. It's just a style thing. Sometimes you'll see people do this instead. They'll put like m underscore fish. There's a few different styles to denote it, but basically what we're trying to do here is it helps the programmer recognize that this is a special private member variable. It's not a local variable like one of these. So when I'm going through my code, I know these are all local variables because there's nothing there. But up here, I know that this is a private variable because I've put an underscore after it. So that's the style that I use for it. You'll find that you're going to want to pick a style to work for you because, again, looking through the code, I know just by seeing it, this is a special variable. It's actually the member one, not a local variable here. So, again, the reason too is if this has something to do with the state of the game, like fish count certainly will have something to do with our score, then we want to be aware when we're changing it and say, oh, okay, I better be careful. This is actually the fish count that belongs to the shark. It's not just some variable I created as part of my method. Okay, so in here now, we have to do the code for eating a fish. First thing we want to know is, did you find a fish? So I'm going to make a method here. Public Boolean found fish. Okay, so now in here I want to know if a fish was found. So I'm going to use that intersecting object method again. So here's the method get one intersecting object, but this time I'm going to actually specifically be looking for a fish because it can't eat the submarine and it can't eat a torpedo. So this time I'm going to say get one intersecting object, and I'm actually going to call on the fish class. Before, if you remember, I had to put in null here so it would get me every kind of actor. If nothing was found, it returns the null address. So as long as a is not equal to null, that means there is a valid actor here. So down here now, if I found a fish, I also want to be able for the shark to eat the fish. And that's a void method. It doesn't return anything. So in here, what I'm going to do to eat the fish is I'm going to use the same method so I know which one I'm eating. And I'm going to say I have a world, and world.remove object. Now the fish has been eaten. But there's one more thing I want to do here. I want to update the fish count. So I'm going to increment the fish count. I actually want the private member one to be incremented. So now this variable here that belongs to the shark, it's been increased every time it eats a fish. So get the actor that I've just run into and remove it from the world and increment my fish count. It makes sense that we put this code here and not in the act method, because in the process of eating a fish, I've just increased the count of fish that I've eaten. So it makes sense that they belong together. So to update my code now in here, I can say if I found a fish, because this is where I've just finished moving. The move happens here. Now that I've moved, if I found a fish, eat the fish that I found. So let's compile this. And now we're going to get that behavior of a shark actually being able to eat. So I'll put a fish in the world. Let's put the fish here. So now when I run it, my shark can tease him a little bit and grabs the fish. Now, you notice when you right click on the shark, let's pause it for a sec, I can't actually find out what that count is. There's no way to access it. And the reason is a private member variable, we can only call through its functions. So here, if I want to actually get access to this fish count, and it makes sense that I do have access, how am I going to know what the score is? I have to let somebody see it. So public int get fish count, and here I'll return the fish count. So you might think that this is redundant. Like, why would you do this? Why not just make the fish count public so that anyone can see it or use it? Why make them go through a method like this, especially such a simple method? Well, first of all, we call these methods accessors because they give us access to the private members. And just the fact that we have a special term for them means there's a reason they're there. And that's that we don't want anyone messing with this unless they do it through the proper interface. And the proper interface is the method here. So what I mean is, you're allowed to look at the fish count, but if I just made this public, you'd have complete access to it. You could go and change it any way you wanted. And you might change it in a way that I don't expect, and now all of a sudden my program doesn't run properly. So basically what we're doing is hiding that information on purpose. We're saying, if it's appropriate, I'll let you have access, but you can only see it. This is not going to be a number that you're allowed to change. It's just going to let you peek at the value. So it's important with your private member variables that you think about how you're hiding them on purpose and only allowing for the access through these methods. Okay, so now I can get a fish count. So let's compile it, and you can see so far kind of what the world looks like. So we'll put a shark in here, and I'll put a couple of fish in here for it to eat. And maybe I'll bring it up a bit. Okay, so let's run the world. I'll go grab this guy, and then I'll go grab this guy here. And Now I'll ask, what is the fish count? 2, because I ate 2 fish. So I'll reset the world. That's the shark then being able to eat fish and move with the keyboard, as well as keep track of how many fish it's eaten. The last thing we need to add is the sub. So coming up in the next video, we'll finish off our game and add our villain here who's trying to shoot you with torpedoes.